Good morning. So today we're going to look at solving trig equations. So we're going to spend about 2 days working through solving our trig equations. So when you want to solve a trig equation, you can have no solution. Okay, so a trig equation can have no solution, one solution, or multiple solutions. Depending on the interval that it's going to be defined in. Okay, so to solve a trig equation, we want to isolate the trig functions. We also may, when we isolate it, we may have to use some identities. So that's what we're going to do as well. So we're going to do basically this first page today, and then tomorrow do the back page. And that's going to be more of your identities page. Okay. So this says solve for the equation for x on this defined interval here. So between 0 to 2 pi. So that means on one full rotation of the unit circle. So where is sine going to be equal to a 1/2? Basically this one's isolated enough. So where is sine going to be equal to a 1/2 on the unit circle? And that answer is going to be pi over 6, right? Because it is a 1/2 at pi over 6. And then it's also going to be what, 5 pi over 6? And that's where it's going to be equal to a 1/2. If it would have said sine of x is equal to a negative 1/2, then that would be your lower two quadrants, right? So knowing your unit circle is key for all of this. All right, so let's look at number 2 here. For number 2 here, I want to isolate, so I want to get my two sines together on opposite sides. So very similar to how you would in an algebra problem. So you are just going to subtract that whole entire thing over. So you'll subtract it here. So when you do that, then you could go ahead and add 2 over here. So 3 sine x minus a 5 sine x is going to give you a negative 2 sine of x. And then negative 1 plus a 2 is going to give you a positive 1. Isolate this, so you are going to divide both sides by a negative 2. So you will have now sine of x is equal to a negative 1/2. So where is sine of x going to be equal to a negative 1/2? So my interval here that I'm going to be looking at is going to be in between negative infinity to positive infinity. So for that one, it's going to be a lot of different answers, but I need to go ahead and find the two values that it's going to be. So where is sine going to be equal to a negative 1/2? And that is going to be what, 7 pi over 6? I kind of gave away my answer just a second ago. And then what, 11 pi over 6? Okay, so with these two things, that is a 7 pi over 6 and an 11 pi over 6. But with these two values, it's going to be repeating. So I can also say that this is also going to be 2n pi. So if I add 2n pi every time, that's going to give me my values throughout negative to positive infinity. Okay? All right, so I want you to do number 3 and number 4 for me real quick. So try number 3 and number 4 for me. Okay, so same thing here. I want to combine my cosines here on both sides. So if I combine, I'll I'll subtract my 3 here, so this will be a 2 cosine of x plus square roots of 2 is now going to be equal to a 0. If I move my square root of 2 over, I don't know what that notation was right there, but that should be a cosine. If I move it over, it becomes a negative square root of a 2. If I divide both sides by 2, then this will be cosine of x is going to be equal to a negative square root of a 2 over a 2. So where is cosine a negative square root of 2 over a 2? And that answer is what, 3 pi over 4. And then again at what, 5 pi over 4? The domain here is what my values I want is going to be in between negative infinity to infinity. So this is when I am going to add that 2n pi here. Good deal. All right, so let's look at number 4 here. So number 4 says cosecant of x minus 6 all over 4 is equal to a negative 1. So I'm going to multiply both sides by a 4. So I will have cosecant of x minus a 6 is equal to a negative 1 times a 4, which is a negative 4. I'm going to solve for cosecant, so I am going to add that 6 to both sides, so that will be a 2. So cosecant, I want to figure out where cosecant is equal to a 2, or where sine of x is equal to a 1/2, right? Because cosecant is the reciprocal of sine. So where is sine going to be equal to a 1/2? And so that's going to be what? Pi over 6. And also again at what, 5 pi over 6? But this is between negative infinity to infinity, so I am going to then add the 2n pi. And that just means that n is just some kind of integer inside there. Okay. All right, I'll try number 5 and number 6 for me. Okay, so if I subtract here, so I'm going to subtract 10. So I'm going to be left with the 2 tangent of x is equal to a negative 2 divided by 2. So this will be tangent of x is equal to a negative 1. So where is tangent going to be equal to a negative 1? So that's going to be where your x and your y values are the same. So that is going, and so square root of 2 over 2 basically. So this is going to be any pi over 4, but it's got to be a negative. So where your x and your y values opposite signs. And so that's going to be in the second quadrant. So that's going to be 3 pi over 4 and then 7 pi over 4. Good. All right. So let's look at number 6 here. So number 6, if I subtract my 8, so I'm going to be left with 4. Sine squared x is going to be equal to 11 minus an 8. Is your 3. Divide both sides by 4, so you're going to be left with sine squared is going to be equal to a 3 over a 4. Well, for this one, you can, just like if you did this in an algebra class, you could isolate, so you could basically take the square root of both sides, and you will be left with one sine x. And we take the square root, you'll be left with plus and minus, and this is going to be square root of a 3 over square root of a 4 is a 2. So it'll be over a 2 there. All right, so where, and this is going to be in the third quadrant, so where is sine either positive or negative square root of a 3 over a 2? And it's going to be negative, so this is going to, my x value here is going to be 4 pi over 3. Okay. All right, so let's look at 7 here. So 7, we've got 4 cosine squared. Sorry. 4 cosine squared x minus a 1 is equal to a 0 here. So I need to, same thing, isolate here. So we would have 4 cosine squared x is equal to a positive 1. Divide both sides by 4. So you'll have a 1/4. And then take the square root of both sides here. So you will have plus and minus a 1/2. So we are looking from the interval from 0 to 2 pi here. So where is cosine positive and a negative 1/2? And so that's going to be all of your pi's over 3's. So it'll be pi over 3, 2 pi over 3. The next one would be 4 pi over 3, and then 5 pi over 3. Okay. You could have also done this one by factoring, right? So that's what we're going to be doing here for number 8 here. So factoring is going through and treating it like a regular algebra problem. So if I wanted to look at this one, I have a square term and I have a normal term and then I have a constant here. So if I were to look at this and if I wanted to let, so let's just let y equal cosine of x. So y is going to represent cosine of x here, okay? So this is going to turn into 2y squared plus a y minus a 1 is equal to a 0. And so this is just a regular algebra factoring problem. So I want to figure out what multiplies together to give you 2 or negative 2 and adds together to give you a 1. So this will be able to factor to 2y and a y, right? And one is going to be negative, and then the other one would be a positive one like that. So let's just check it. So 2y times y gives you 2y squared. 2y times 1 is a 2y, negative y. So that adds together to give you a y, and a negative 1 times a positive 1 is a negative 1. Okay, well we let y equal this cosine of x over here. So this can turn into 2 cosine of x minus a 1, and this one would be just cosine of x plus a 1. And then we would factor, so we set both of those equal to a 0. Okay, I need some more paper, so I'm gonna come down here. Can y'all see this right here? Okay. So I'm gonna rewrite this one. So this is gonna be 2 cosine of x minus a 1 equals a 0, and then cosine of x plus a 1 is equal to a 0. Okay, all right. So we have two equations, so we'll have 2 cosine of x is equal to a 1. So cosine of x will be equal to a 1/2. And then this one would just be cosine of x is equal to a negative 1. All right, so where is cosine of x going to be equal to a 1/2? And I'm going to be in the first one, all 4 quadrants. So where is cosine of x going to be a positive 1/2? And that answer is going to be pi over 3. And then again at where? 5 pi over 3. So where's cosine of x equal to a negative 1? So where's your x value going to be negative 1 on the unit circle? And that is going to be at pi. So those are your answers there. So pi over 3, 5 pi over 3, and also at pi. You also need to make sure that your solutions make sense and they are accurate, especially for like number 9. You have 2 different functions inside there, so you do need to make sure that they are true. Okay, so I want you to try to do number 9 and number 10 for me. So we need to get everything to one side. So we're going to get the cotangent of x. Remember, when you factor, you get everything to one side. So if I move it over there, I subtract it. And that whole thing is together. I can factor out a cotangent of x, and I'll be left with 1 minus a sine squared x. I can set both of those equal to 0, so cotangent of x is equal to a 0, and then 1 minus sine squared x is equal to a 0. So this will be a negative sine squared x is equal to a negative 1. So this will be sine squared x is equal to a positive 1. So where is sine going to be plus and minus a 1? And where is cotangent going to be equal to a 0? So cotangent is cosine over sine, right? So don't forget about that. So where is cosine over sine equal to a 0? So cosine over sine, where is that going to be equal to a 0? So where? So x values are going to be, what, pi over 2? And then 3 pi over 2? And where is sine going to be equal to plus and minus a 1? So add what, pi over 2 and what, 3 pi over 2. Good deal. All right, let's look at number 2. Or number 10, I'm sorry. So number 10 says 2 sine squared x plus a 3 sine x minus a 2 is equal to a 0. And this is in between 0. Oh, hold on. Let's go back to this one. Sorry. This is in between pi and 2 pi, right? So in between pi and 2 pi. So my only answer here is going to be that 3 pi over 2. I'm sorry. That's going to be in your third and fourth quadrants. So, my bad. Alright, so let's go this one again. So this one says 2 sine squared x plus a 3 sine x minus a 2. So you can do that substitution like we did up here, or you can just think about it and just know that this first term is just going to be the single version, like that. Alright, so then here we would have a 2, so one needs to be a negative and then one needs to be a positive. So I think that would be it. So 2 sine x times sine x is a 2 sine squared x. 2 times 2 sine x is a 4. Minus a 1 is a 3. And then a negative 1 times a 2 is a negative 2. Okay. We'll set both of those equal to a 0 now. So here we'll have 2 sine x is equal to a 1. So sine of x is equal to a 1/2. And this one would be sine of x is equal to a negative 2. Yes. So where is sine of x equal to a positive 1/2? And that is what, pi over 6 and what, 5 pi over 6? And then this one is nowhere to be a negative 2, so that value is not going to exist. Okay. All right, let's look on the next page here. So on the next page, so I want you to try to do number 11 for me for homework. We'll start with that one on Friday. So we'll start with that problem. We'll start up with that one. Okay, so start with this one and then do your homework for me. Okay, if you have any questions, let me know. Y'all have a good day.